Welcome back to our channel Flying Colors. Today let's see another topic, data types. From the name it is understood that it specifies the type of data we want to store. Like in the real time where we mention liters for liquid and grams for weight, just imagine this to be a unit for the data we are trying to store. So our agenda for today is to understand the purpose of data types, its types, data type modifiers, range of each data type, and finally the examples. But before getting started, please do like, subscribe and click on the bell icon for more videos on C. Coming to the purpose, we basically use data types at the time of declaration of a function or a variable. Each data type requires different amount of memory and has some specific operations which can be performed over it, which in turn helps us to estimate the memory space the variable is occupying or the type of parameter expected by a function. Proper utilization of a memory can be done when suitable data types are used. So this helps the compiler to understand the data it is storing and also the operations that could be performed over it. This is the syntax of the data type. Data type space variable name, and here is the example where we are using integer data type for the variable a at the time of declaration with or without its definition. So here the variable a will store the value 90 and here it will store some garbage value as there is no storage class specified here and will be treated as an auto variable, which was already discussed in our storage class video. Please do watch if you haven't. Next comes the types. There are three major categories: primary, derived and user defined. There are 5 primary ones and those which are derived from the primary are called derived data types, and the user-defined data types are the ones which allows the users to define a variable representing an existing data type. Let's look more on the derived and user-defined data types in the upcoming videos. This video covers the primary ones. Now let us look into each data type. The first one, int. Integer data type is used to store the whole numbers without any decimal values. From our number system, we can store all except binary values, that is, the octal values, hexadecimal values and the decimal values in an integer variable. And we can determine the size of an integer data type by using the size of operator. And the size of an integer data type is generally a compiler or processor dependent. If the processors are 16-bit, then it occupies 2 bytes. And if the processors are 32-bit, then it occupies 4 bytes. And we can perform all kinds of arithmetic operations on an integer variable. Now let us see the range of an integer data type considering a 16-bit compiler, which occupies 2 bytes of memory. And the least value that can be stored is all zeros. And the highest value will be all ones. Here the value will be 0, and when the number is all ones, the value will be, here you can see there are 2 bytes all ones, the value is 65535. So the range of an integer data type is between 0 to 65535. The second one, floating point data type, which is usually used to store large values as it occupies 4 bytes of memory, and it is used to store the decimal numbers with a precision of 6 digits after the decimal point. And we can perform the usual arithmetic operations on the floating point data type variable. Now let us look into the third one, character. Character data type is generally used to store a single character or a symbol, and it follows ASCII standards. ASCII stands for American Standard Code for Information Interchange, and the number that is assigned to a character is called the ASCII value. It is a code which uses numbers to represent characters, and basically when you type any character in the code, be it a semicolon or even a bracket, it first gets converted to an ASCII value before getting converted to a machine language, zeros and ones. We have to always ensure that we store the data in single quotes for a character data type, and the sizes of 1 byte and we can also perform addition and subtraction operations on a character data type variable. This is the ASCII table. Here the blue colored ones are the ASCII values, and here we can find the characters. So the ASCII value 48 to 57 is assigned for the numbers 0 to 9, and 65 to 90 is assigned for the capital letters A to Z, and 97 to 122 is assigned for the small letters A to Z. Let us look more on this in the examples. Coming to the next one, double, which is used to store very large values with high precision of 14 digits after the decimal point. Since it has more precision, it occupies double the memory as that of float, that is 8 bytes of memory, and it is comparatively slower than float as it processes huge data, and we can perform the arithmetic operations on the double data type variable. Coming to the last one, void, which literally means nothing. So it has no value and we cannot perform any operations. Please note that we cannot create any void variable. It is only used for a function declaration and definition, which returns nothing to the caller. Coming to the data type modifiers, it is used to specify the range of the data type more precisely. There are 4 modifiers: signed, unsigned, long, and short. So these modifiers will generally be used before the data types at the time of declaration. Example: at the time of declaring any variable, we mention it as signed int A. And from the name itself, we can identify that the signed integer can store both positive and negative data, whereas the unsigned stores only positive ones. If there is no modifier specified, then it will be treated as an unsigned. Coming to long and short, irrespective of the compiler and the processor, long will always store 32-bit data and short will store 16-bit data. This might not make a difference between int and short int in a 16-bit compiler, but in a 32-bit compiler, the size of an int will be 4 bytes, but the short int will be only 2 bytes. Let us consider the example of an integer data type where the range is between 0 to 65535 in case of an unsigned integer in a 16-bit compiler. But in case of a signed integer, the MSB bit, that is this one, it represents the sign, that is positive or negative, and the rest of the bits is used to store the data. So the range gets reduced due to less number of bits. So in the MSB bit, if it is 0, then it will be considered as a positive number, and if it is 1, it will be considered as a negative number. So the least value that can be stored in case of a negative integer will be 1 followed by all zeros. So now let's check the value. So let this be 1 followed by all zeros. So the least value that can be stored in a negative side will be 32768. And the highest number that can be stored in case of positive integer will be all ones except this digit, which will hold 0. So let us check the value. So here we can see the value to be 32767. So the range of a signed integer will be minus 32768 to 32767. Let me tell you another way to find out the range of an signed integer. So here for an unsigned integer, it holds the values of 65536 including the 0. So when we divide this value by 2, let's see what's the value. It is 32768. We divide it by 2 because we have to split it both equally to positive and the negative values. Since we include 0, on the positive side it will become 32767. It is same as the one which we have seen it earlier. So the range will be between minus 32768 to 32767. You might wonder what happens when we store a value greater than the range specified. You think the compiler will throw an error? Definitely not. Surprised? Let's now check how that works. Let us imagine this to be a pinwheel or a clock. It rotates in the same direction in which it has started. So in case of a signed integer, the positive integers get stored in the clockwise direction and the negative values get stored in the anti-clockwise direction. Now suppose you want to store a value greater than 32767, that is 32769. So here you see 32768 minus, and here it will be minus 32767. So your positive value 32768 will be here and 32769 will be here. But the actual value present here is minus 32767. So this value will get stored. And in the same way, if you want to store minus 32769 in the negative direction, but the limit is only till minus 32768. So then it moves one position ahead in this direction. So here it becomes minus 32769, but the actual value present here is 32767. So now this value will get stored. Now coming to unsigned integer, it completes one full round until it reaches the value 65535. And if you want to still store some values greater than that, it will again start from 0, 1, 2, 3. For example, if you want to store 65537, then here the value will be 65536 and 65537 will be here, but the actual value here is 1. So now this value will get stored in the variable, and this concept is called as overflow. Same thing happens when we store a value less than its range, and that is called as underflow. Let us consider the example of a payroll team in a company which actually stores a huge data of employees. Say the name of the employee, employee ID, taxes paid, reimbursements, leaves taken, gross salary, etc. So the data types here plays a vital role which helps to categorize each field and store the data efficiently. That is, the character data type can be used to store the names, employee ID and leaves taken can be stored in integer data type, and taxes and gross salary can be stored in floating point data type. There's no point in storing all the data in a single data type thinking it would become easier to program, but it will unnecessarily occupy a lot of memory, reducing the efficiency. Here I have summarized the range of all the data types, and please note the size, range and format specifier for the most commonly used data types, that is character, unsigned integer, signed integer and float. And these format specifiers will be used in the printf statement, and the one which is used for character data type, it is %C, and %U is used for the unsigned integer, and %D is for the signed integer, and %F is used for the float data type. Let us now see some of the examples. And please note, the compiler which I am using here is of 32-bit. Here we can see I am trying to assign a value which is one number greater than the maximum value, and the range is specified here. So when the control moves in the positive side direction, so this variable will store the last value on the negative side, which is the same number as this one. So the variable a will store the same value with a negative symbol. And here it will be treated as an unsigned integer since there is no modified specified here. And since the value is within the range, the same number will be stored in the variable b. And again here I am trying to assign a value which is one number greater than the maximum value. And since it is an unsigned integer, it starts over again from 0 once it reaches the maximum value. So here we will be storing the value 0 for the variable c. And the variable d stores the size of the integer variable, which is 4 bytes. As I have already mentioned, the compiler is of 32-bit. Please note the format specifiers for the signed integer type data is %d, and for the unsigned integer type it is %u. Let us now run the program and check the output. Here we can see the size of the integer variable to be 4 and the negative value getting printed here, and the value which is assigned to the variable b is getting printed here, and finally the value 0 which is assigned to the variable c. And these two are the examples for the overflow concept. This is the example of a character data type. So here I am trying to assign a decimal value 48 to the variable a, and since 48 to 57 is specified for the characters 0 to 9, the variable a stores the character 0. And same way the variable b stores the small alphabet a, as the range 97 to 122 is for the small alphabets a to z. And here c is initialized with 0, and here d is assigned with 37, which must be some symbol. Let's check. So the ASCII value 37 corresponds to the percentage symbol. And here I am trying to assign a value which is greater than the range of the character data type, which is 0 to 255. Due to overflow, it again starts from 0, and 305, which is 50 greater than 255. But since 0 is also included, the ASCII value will now be 49, and the character corresponding to 49 is 1, because the numerical starts from 48. And the format specifier used for the character data type is %c. So here we are trying to print the character which is stored in the variable a, which is 0, and the decimal value will be printed here because the format specifier used here is %d. So the value will be the same, 48. And the character stored in variable c will be printed as the %c symbol is used, and the value in c is b plus 2, which is 97 plus 2, 99, and the character corresponding to 99 will be small letter c. C will be printed here, and as we have already seen, d will print the character variable 37, which corresponds to percentage symbol, and e will print 1. So now let us check the output. So here we can see the output to be same. This is the example of a floating point data type, where we are storing the value of 5 to the float variable a, and here we are storing the size of the float variable inside the variable b. The format specifier for the float variable is %s, and here it prints the value 5 followed by 6 zeros after the decimal point. And if we want to specify the precision, we can mention like this: a decimal point and a number of digits you need. So here it will print the value 5 followed by 10 digits, as I have mentioned here, the value as 10. And finally here it prints the size of the float variable, which is 4. Let us now run the program and check the output. As discussed, here we can see the value 5 getting printed with the 6 digits after the decimal point, and here we can see 10 digits, and finally the size of the float variable, which is 4. That's the end of the topic data types. Let's meet again in another video.